Continuing with section 7.2, in the last video we saw how to find the integral of sine cube x and cosine squared x, and in the same way you can find cosine cube x and or sine squared x. So in other words, we looked at what happens when we have the simple odd and even powers on these functions. Now in general, this is what you can think, or you can use always, that if n, so if you have a function with n as a power of sine and m as a power of cosine, so if n is odd, means m can be anything, m can be odd or even. So if n is odd, you will convert all but one sine into cosine using the Pythagorean identity. So remember, the Pythagorean identity is cosine square x plus cosine square x is equal to 1. So sine square x plus cosine square x equals to 1. That's what the Pythagorean identity is. So if you have an odd power of sine, then you can always change it to keeping one sine separate and the rest of the sign with the even power, and then you can apply this identity as many times as you want, or you can use it as a power of the even power of the sign. So but once you simplify that, then you will make the substitution, and the substitution will be that you will take the u to be equal to cosine of x, and then you will go from there. In the same way, if m is odd and n can be anything, then we will again can use similar situation, that we will use the Pythagorean identity to change the cosine into sine, and then use the substitution u is equal to sine x. On the other hand, if m and n are both even, then we will use the half angle identities, which I showed you in the last videos. So looking at the next example, if you notice, we have sine square x times cosine of 5x. So you can see this is the second case over here. So we have a odd power on cosine. So we should write it as sine square x times cosine of 4x times cosine of x dx. So cosine 4x is actually cosine square x whole squared. So which means we can write it as 1 minus sine squared x whole to the 2. And now we can expand it by using our, or we can just leave it as it is now and then plug it in there and then use substitution, or you can first expand it and then use substitution. That's your choice. But anyhow, so if I leave it like this, so my given expression or given integral becomes now, so sine square x times 1 minus sine square x whole squared cosine of x dx. So we can now make a substitution. So let u equals sine x. So this gives us du equals cosine of x dx. And now go back and substitute. So our integral becomes integral. So if first one is sine square x, so it means it is u squared. And then over here I have 1 minus u squared whole squared. And the cosine x dx is du. Now this became simple. Simple algebra can apply and then integrate. Distribute. So this is just algebra here. And now we find the antiderivative. So which is u cube over 3 or 1 over 3 u cube minus 2 times u to the 5th over 5, or 2 over 5 times u to the 5th, plus u to the 7 over 7, or 1 over 7 u to the 7 plus the c. And then now put the u back in terms of x. So we have 1 over 3 sine cube x minus 2 over 5 sine of 5x plus 1 over 7 sine of 7x plus c. So that is the antiderivative. Looking at the next example, okay, so now here we have both powers are even. So we have to use the half angle formula for both. So remember what is the half angle formula? That's, well, you can look at it like this as well. So one form is what I have up there, but you can also look at it like this. And cosine square x is 1 plus cosine of 2x over 2. So I'm going to substitute here. So this gives me multiply it out, the bottom gives me 1 over 4, and inside I'm getting 1 minus cosine square of 2x dx. Now recall that this formula in general can be expanded. So for the cosine square of 2x will be 1 plus, so we will use this formula now, cosine of 4x over 2. So that 1 plus cosine of 4x over 2 and whole thing dx. We can now expand it or combine the like terms. You can see there is 1 here, and we will be getting a 1/2 minus 1/2 from inside. So I'm going to get 1 over 4 integral of 1 minus 1/2 minus 1/2 cosine of 4x dx, or 1 over 4 times 1/2 minus 1/2 cosine of 4x dx. So we can integrate here, or we can pull out the 1/2 so that it becomes 1/8 1 minus cosine of 4x dx. So if you now want to use the substitution again, so use the u equals 4x, then du will be 4 dx. So first integral is 1 over 8x, then I have 1 over 8 integral of cosine of u 1 over 4 du. So that 1 over 8x minus 1 over 32 sine of u plus c, which then gives 1 over 8x minus 1 over 32 sine of 4x plus c. Okay, so the next one is the so this is cosine raised to the power 4x. So in this case we are going to use the half angle formula for cosine square, which we already know is, so this can be written as integral. So remember the cosine, this can be split as cosine square x whole squared, so that 1 plus cosine of 2x over 2 whole squared which is going to be 1 over 4 times integral 1 plus 2 times cosine of 2x plus cosine squared 2x dx. So a lot of algebra in here, and of course trigonometry, and then calculus, and then calculus 1, and then calculus 2, of course. So again, remember, we have to apply the half angle formula on this one. The other two pieces we can separate and actually integrate if you want, or you can do the integration all together at the end. So I will have 1 over 4 integral 1 plus 2 cosine of 2x plus, so cosine square of 2x will be 1/2 plus 1/2 times cosine of 4x dx. So now we can see that these two numbers combine. So we get 3 over 2 . So we have 1/4, and then inside the integral we have 3 over 2 plus 2 cosine of 2x plus 1/2 cosine of 4x dx. And now we can anti-differentiate. Now you might say, okay, I have to do the substitution. Well, by now you might have noticed how the substitution works, but if you want, you can maybe go on a side and do the substitution. So when you take u to be 2x, your du is 2 dx, so that your integral of cosine 2x dx becomes 1/2 integral of cosine of u du, which gives you 1/2 sine of u or sine of 2x. In the same way, take v to be 4x, then dv is 4 dx, so that integral of cosine of 4x dx becomes 1/4 integral of cosine v dv, which gives us 1 over 4 sine v or sine 4x. And now we can bring that over here. So we have now 1 over 4 times 3 over 2x plus 2 times, so remember the antiderivative of cosine 2x was 1/2 sine 2x. So we have 1/2 sine 2x plus 1/2 times, so the integral of cosine 4x was 1 over 4 sine 4x plus c. This actually, maybe we will call it c1 or c prime, because we have to multiply it out with 1 over 4, so that will be our c. So we get 3/8 x plus 1/4 sine 2x plus 1 over 32 sine of 4x plus c. So that is our final answer. So this is how you use either the Pythagorean theorem or the half angle formulas for cosine and sine.